Hello, we are the Applied Health Data Hub group, a team of 3 data scientists working on a project with the Applied Health Performance Science with the athletics at the University of Utah. My name is Matthew Newson. I worked on the machine learning model as well as helping with some of the data cleaning in our pipeline.
My name is Atticus Benson, and I worked primarily on developing the visualization front end to provide some interactive insight on our machine learning model, as well as help develop that machine learning model.
And my name is Ellie, and I worked on the AWS pipeline for all the performance data that we are working with.
Just a quick introduction of our project. We work to create an end-to-end pipeline for the Utah Athletics, making all performance data from practices and game days ready to query and easy to use for the interns at the department. We paired this with a machine learning predictive model that predicts player workload, how hard players work at practice, and we used an intuitive visualization and front end to demonstrate this. The main stakeholders of this project were obviously the interns at AHPS. This allows them to have secure access to all of this data from multiple vendors and be able to pull this into their own projects without the need for multiple API calls, and it prevents them from having to statically download and manually clean Excel spreadsheets. They're able to use this that's already cleaned and already being able to put into their systems. Additionally, with our predictive model, coaches and staff members can look at it to predict practice plans in the future, and then to kind of monitor and predict player workloads, reduce injury risk, those kind of things. Just kind of an overview of the pipeline allows us central access to all of our vendor performance data. It is query ready, so you're able to query this data with SQL instead of having to look through actual Excel spreadsheets. And it also is secure and is much safer than storing the data in spreadsheets. Our predictive model / visualization, it predicts the player load, how hard a player works at the upcoming practices based off of their old work at practices. And then also we have some side-by-side player comparison and flagging for a player working too hard at practice based off of our projections.
Now I'm going to demo how an intern would go onto our AWS system and pull keys to then be able to query the data. They would log on to the athletics server where they can navigate to their browser and Beyond Trust, which is our secure UIT system to getting onto any cloud services. They'll go to their passwords safe and then download this RDP file, which will then navigate them to AWS Access Portal, where they will then see the different role-based access groups. As an intern, they will use the read-only role, and they can click the access keys link here to copy all the credentials that are on an 8-hour rotation. Once they grab those keys, they can navigate to the IDE of their choice, and in their terminal, they will go ahead and say AWS configure. And with each prompt, they can paste the keys. And for the purpose of keeping them secret, we have pre-entered these. Here is an example of how an intern would be able to use a notebook in VS Code to query any of the data that they would like from our AWS system. After pulling down the keys like discussed, they can create a SQL-like query. For example, here I have one for the vendor device where we test jumps in the weight room. And as you can see, they're able to make a SQL-like query and then run that, and it pulls down the data from AWS into a data frame. Here's an example of that. And then from there, they can go ahead and do any of their exploratory data analysis, feed this into web apps or dashboards.
So as Ellie mentioned before, there are a variety of use cases for our interns, and for our project specifically, we chose to make a locally hosted web app to demonstrate the capabilities of our system in an environment that an intern would actually use. So here we have our dashboard that's created where we can actually view all of the historical catapult data. We have the option to select between different athletes here. We can select a different date range. So right here we have selected all of the years from 2021 all the way up to 2026, but we can click around, we can shrink different months, different years, whatever we want to find, we can click around and select different things. We also have here a week-by-week view where we can select in a more readable, digestible format the bar chart view of the actual data day by day within any week, and we can scroll through and select any different week all the way from the very beginning of our catapult recordings up until the end. Another functionality that was requested by the staff was to actually be able to compare these bars and the data to the athlete's lifetime mean. So upon rendering of the visualization, we also calculate that lifetime athlete mean, which we can display. And then we also have the ability to display the team average over these different days to see where an athlete performed against the team. Similarly, we also have multiple player comparison capabilities where we can select one or more different athletes to compare against each other. Again, this is visualizing player load over time, which is like the gold standard Catapult metric that Catapult tracks. Inherently looking at how much load or how much work is on a player's body day by day. Again, we have the date range view as well as the weekly view that we showed off before. We can show the lifetime means and as well as the team means over that time. This is the line chart form, but we also have that bar chart form. Finally, to visualize our player load prediction, we can select an athlete here and find their prediction for any day since we started making those predictions. So we started on February 25th. That's what you guys are seeing right here. We can see that the planned load for that day was 500, and the athlete was predicted to be above that load at 597. Additionally, you can see down here in our table that we also show the percent difference from the mean. This is because the threshold for a significant difference would be a 20% difference from the team predicted mean. And so as we can see here, we can show this team predicted mean. We were 597. The predicted mean for that day for the whole team was 535. And finally, to show one more capability, on specific days, specific athletes might be predicted to actually fall above or below this 20% over or under mark. And when we do, we can get this alert flag right here to be able to easily visually see which athletes are over or under that mark and which athletes might need to be flagged and shown to coaches for further decision making. For our system architecture, we chose an AWS cloud-based architecture to contain our entire system. To start, we used AWS Lambda to ingest the data from our Vault and Catapult devices. We used AWS Secrets Manager to support this by storing our API keys in a secure and encrypted way. We then used S3 storage for the raw data, which comes in a JSON format. From there, we used AWS Glue to actually transform and flatten this data into a more readable Parquet format. Then that data was put back into a clean S3 bucket, which is then where we used Glue crawlers to crawl over that data, log the schema, check for changes, and then be able to be used in AWS Athena to actually query that data. From there, to develop the ML model, we used AWS SageMaker, which is Amazon's built-in ML development platform. And then finally, we worked with UIT to be able to develop different user roles within the AWS system so that they can get those keys that we showed earlier on in the demo and then use that inside of whatever IDE they want to, whether that be VS Code, RStudio, to suit their own personal needs.
We used GitLab as our project management tool and were able to close 61 issues throughout the course of these 2 semesters where we worked on this. Additionally, we conducted a user study with 15 different applied health and performance science interns and 2 different staff members that work in the department. Through their input, we were able to adjust a few things and make this project something that should be used in the department for years to come. Thank you for listening to our video.